this session, we are going to learn the concepts on units and measurement and theory of errors. Physics is a science of measurement. All physical quantities have to be measured and quantified. For example, if you take an object, you have to find the mass, you have to find the density. If it is moving, you have to find the acceleration, speed, etc. So, first of all, we have to know the system of units in which we are going to make the measurement. So, the latest system is System International, in which we have the following fundamental quantities: length, mass, time, temperature, amount of substance, luminous intensity and electric current. So, in this system there are 7 fundamental quantities. The respective units are given: meter, kilogram, second, temperature in Kelvin, amount of substance in mole, luminous intensity in candela, electric current in ampere. In addition to this, we have 2 supplementary units, that is the plane angle radian and solid angle steradian. Any physical quantity has to be expressed in terms of these units of the fundamental quantity. For example, if you take volume of a body or say volume of this room, so volume is equal to length into breadth into height or thickness. What is the unit we are using for this? Meter, 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 or volume, unit of volume is meter cube. Similarly, if you take density, which is mass per unit volume, its unit is kilogram per meter cube. Okay. Now, we talk about fundamental quantities and derived quantities. Fundamental and derived quantities. Fundamental quantity is length, mass, time and other 7 factors we have seen. Derived quantities are physical quantity which are expressed as a combination of this. For example, volume. Volume equal to, we can say volume is length power 3. So, we can express the dimension of volume as mass power 0, length power 3, time power 0. Which means this is the dimensional formula for this physical quantity. So, fundamental quantities are these 7 quantities I mentioned. Derived quantities are quantities, physical quantities which are expressed as combination of these fundamental quantities, and the power of these fundamental quantity to which we raise them is the formula is called as the dimensional formula. So, first of all, we are going to discuss about the dimensional formula and the application of dimensional formula. So, any dimensional formula you can write from the fundamental equation. I will give a small example. Take angular momentum. How do we define angular momentum? It is defined as moment of linear momentum. Moment of linear momentum about the center of rotation. So, linear momentum is mv, its momentum about the center of rotation is mv into r. So, the angular momentum L formula is mvr. Now, let us write the dimensional formula which you indicate by square bracket. Mass, dimensional formula for mass is m. Velocity, velocity is distance by time, distance by time. So, L t minus 1. Distance, r is distance, so L. The dimensional formula for L is m L square t minus 1, m L square t minus 1. In this way, you can find the dimension formula for different physical quantities. Okay. Now, I will explain the application of dimensional analysis. The dimensional analysis helps us to find the dimension of physical quantity and also the dimension of constants, and its application are, we can check the correctness of a given equation. We can check the correctness of the given equation. Take for example, S equal to ut plus half at square. Okay. So, any equation in physics is true only if it is dimensionally consistent. That means you can add and subtract only quantities which are having same dimension. You can add and subtract quantities which are having same dimension, not different dimension. And also, if this is an equation in physics, the dimension of the left hand side and the dimension of the quantity on the right hand side must be same. So this is called as homogeneity of physical equation. What is dimension of S displacement? L. So left hand side dimension is L. If this equation is correct, then this term must give dimension L, as well as this term must also give dimension of L. What is U? Initial velocity, dimension Lt minus 1, time is t. So this becomes Lt minus 1 into t, and then this is acceleration Lt minus 2 time square. Simplify this, you get L here. Simplify this, you get L. So the equation is dimensionally consistent. So we can say this is an equation which is dimensionally consistent. Okay. So this is one application. The second application is you can convert physical quantity from one system into another. Now suppose we have a quantity whose value is N1 in a system where the fundamental units are M1, L1 and T1. The dimensional formula will be M1 power A, L1 power B and T1 power C. Then in another system where we are having a different fundamental unit, say M2, L2, T2, but the dimensional formula has to be the same. So the same power ABC, then N2 is the magnitude of the physical quantity in this system. So N1 is magnitude of one particular physical quantity in this system, and N2 is the magnitude of the quantity in the other system. I will explain this when we do the problem. So in dimensional analysis, we are going to adopt the concepts we have discussed here, homogeneity of physical equation, and you can add and subtract only physical quantity having same dimension, and we can use the dimensional method to convert from one system into another. We are now going to do the problems from the skill builder unit 1. So you can refer to the question numbers I will be writing on the board in this topic, skill builder unit 1.